Algebra 1, Simplifying Exponents. Part A, we're going to focus on positive exponents. Let's start with some vocabulary, definitions, and formulas. So in math, when we talk about the base of a term, that is a number or variable that's being raised to a power. So some examples that I have there for you are 8x squared or x cubed. So 8 to the second power, x to the third power. So we have a number and a variable. Those are our base. Now the little number up and to the right, that's an exponent, and that's a number that indicates how many times the base is multiplied by itself. So here, the 2 and the 3, those are what we call the exponents. And then we also use the word power. And so 8 with the exponent of 2, or 8 squared, 8 to the second power, means 8 times 8, or 64. X to the third power means x times x times x. I mean, who wants to write that over and over? So we do a little shortcut where we use the exponent numbers. Now we're going to talk about how to simplify an exponent term and how to evaluate. In math, simplifying and evaluating are two different things. So when you simplify, you just use the properties that you have and you rewrite, in this case, the exponential term using positive exponents only. When you evaluate, you usually will get a number value. So we're going to rewrite the exponential term, but as a number value. So when we simplify, we just use the properties and usually get it into an exponential form, and then when we evaluate, we get a number value. Let's start with the properties of exponents. These may be review for you, and they may not. They are really important, though, when we simplify exponent terms. So our first property is called the product property of exponents. So these first words are going to change for you. We have the product, the quotient property, and the power property. So the product property, it's a shortcut, and it says when you multiply exponential expressions that have the same bases, that's key, then what you can do with those exponents is you can add them to get your final answer. So let's look at the examples. On A, notice we have x to the 5th times x to the 7th times x. Now this is just an understood first power, but let's go ahead and write that in, if I'm allowed to. Let's see. There we go. So notice the bases are the same. Then in that case, we can simply add the exponents, x to the 5 plus 7 plus 1. So what we'll have total here is x to the 13th power, or x multiplied together 13 times. And that's all we can do, so we've simplified. We can't evaluate. We don't know what x is, the actual number, to raise it to the 13th power and get a number answer. So we just simplify it here. It works the same, though, if your bases are numbers. Now 9 to the third power times 9 to the second power, we keep that same base, we don't change it, and then we add the powers. So that is actually 9 to the 5th power. And then I can evaluate that. So if I put that on my calculator, 9 to the 5th power is 59,049. And then finally our last one, so we have 2x to the negative 2 power, and we can have negative powers. We'll talk about that more in Part B. Times 3x to the 8th. So first of all, we can just multiply our numbers together. 2 times 3, which is 6. And then with our exponent terms, because it's only the x here and here that are being raised to the power. Even though the 2 and the 3 look like they are connected, they actually aren't. They're just sitting next to them, multiplying. So we can take the powers, negative 2 and 8, and we can add them. So 6x to the 6th power. And that's all we can do with that. So that's in simplified form. Now our next property is a quotient property. So now when we're dividing, if you remember quotient means divide, exponential expressions with same bases, we're going to subtract the exponents. Now, the way that I do it is I take the larger exponent minus the smaller, and wherever the larger exponent term started, that's where your term ends up. So x to the 5th divided by x to the 3rd. X to the 5th, so 5 minus 3. Oops. Which is 2. And our bigger exponent term was in the numerator, so our term ends up in the numerator. When there's nothing else in the denominator, it's essentially 1, but we don't need to write that. Now when we have multiple variables, we just do the same thing, but only with like variables. So our x's are going to be 2, and this is the first power, so we'll subtract those. Our y's are 9, and we'll subtract that. And our bigger exponents were in the numerator, so that's why I placed them in the numerator. So it'll be x to the first power, but I'm not going to write the 1. I don't need to. Times y to the 6th power divided by 1, but again, it's not going to change the value, so I don't need to write the divided by 1. Now lastly, it's a lot like a, but it's with the number this time, so I'll subtract my exponents, and I'll get 8 to the 3rd. And again, I can go ahead and evaluate that. Take 8 times 8 times 8, which is 512. Okay, lastly, sometimes you're going to need to take a power and raise it to a power. And when you do that, you're going to multiply your exponents. So we have m to the 4th, and then we're raising that to the 8th power. So we're going to multiply our exponents. So that'll actually be m to the 32nd power. Now when we have multiple terms, we have to take them one at a time. So we multiply. So x to the first power, 1 times 5 is 5. Y to the second power, 2 times 5 is 10. Z to the third power, 3 times 5 is 15. 4 squared raised to the 6th power, the third power, but when we multiply, 2 times 3 will be 6. And then, since we do have a number base, we can go ahead and evaluate that. So 4 to the 6th power is 4,096. On D, we've got a quotient there, but it's different bases, so we can't subtract our exponents, but we can raise them each to the second power. So we're going to multiply. So 3 times 2 is 6. So our power of x is 6, and then 5 times 2 is 10. So we get x to the 6th power over y to the 10th power. Make sure when you write your exponents that you superscript them. That means up and to the right, so they don't look like just a number side to the side of the variable that's multiplying. Now on E, we're going to do the same thing. We're going to raise each of those to the 5th power. So 1 to the 5th power, and then m to the 7th to the 5th. 7 times 5 is 35. Now 1 raised to any power is simply 1. So that would be our final simplified answer.
Hello, so let's look at this independent practice. So in these problems, it says use the properties of exponents to simplify and leave in an exponential form. So notice here it did not say evaluate, so we're just going to leave them in an exponential form. So let's look at number 1. So number 1 here, as you guys can see, we have t to the second times t to the third times v to the second. So as you can see, we have same base here. They both have a t in them. So when you are multiplying the same bases, what you really end up doing is adding up the exponents. So really, I'm going to have t to the second plus that third, and then times v to the second. Because these are different bases, I cannot combine the 2 plus 3 plus the 2, right? Because they don't have the same base. So this here will be t to the 5th power, and then v to the 2nd power, okay? And that's all we have to do for this one. Number 2. So on number 2, it says 7 to the second times 7 to the what will give you 7 to the 7th power. So we're looking for what needs to go in this blank. So as you can see here, we have the same bases, which means we're going to need to add up the exponents. So think of it as 2 plus what gives you a 7? Well, 2 plus 5 will give you a 7, which means up here we have to have the 5th power. 2 plus 5 is that 7th power. Okay? So 5. Number 3. Number 3 here, this is your quotient property. So you have x to the 8th over x. And when we just have an exponent, that really means it's raised to the 1st power, like that. So anytime you are dividing exponents with the same base, really what you end up doing is subtracting the exponents. So this really is x to the 8 minus 1, which is x to the 7th power. Okay. Number 4. Number 4 here, we have some work to do. Okay. So I'm going to treat things differently here. So 2 to the 4th, this is a fraction, right? Think of it as 2 to the 4th. And then you have a to the 3rd over a to the 2nd. Then you have b, right? There's no other b's here on the denominator, so I'm just going to make it over 1. Okay, and then you have, and this is just one of the ways you can go about doing this problem. And then you have c to the 4th over c squared. So I kind of just separated them. So as you guys know, even from middle school, when you have a fraction and it's reducible, you can do that. So here you can divide both sides by 2. So 2 divided by 2 is 1. 4 divided by 2 is 2. So then this fraction 2/4 becomes 1 over 2. These, the a's, so they have the base of a, and when you're dividing exponents with the same base, you end up subtracting them. So this here is really a to the 3rd minus a to the 2nd, which is just a to the 1st, or just a. Okay, b over 1, I can't really do anything there, so I'm going to leave that alone. And also you can make this over 1 if you want, so you know it's on the top, on the numerator, not denominator. And then with this one here, c to the 4 and c over c to the 2nd power, think of it as, well, you're dividing them, so it's c to the 4 minus 2, which is c to the 2nd. So in other words, this here becomes a 2, and this is just a 1. Same thing with this one here, it's just an a over 1. So now on my numerator, I have a 1, an a b, and then c squared. I don't need to put the 1, that coefficient of 1, so I'm literally just going to write it as a, b, c squared, because that's what I have left on my numerator. On the denominator, I have a 2, a 1, so 2 times 1 times 1, and really this one is also a 1. So it's just 2 times 1 times 1 times 1, which is just 2. Okay, so this here simplifies this problem. You could also just, on the problem itself, just reduce it. So this becomes a 1, this becomes a 2. When you subtract the 3 and the 2, this becomes a 1. This is gone. The b stays because you don't have anything else to combine it with. C to the 4th, if you just do 4 minus the 2 from the denominator, it becomes a 2, and this is gone. So you can see that you're just left with an a, a b, c to the 2nd over this 2 right here. That's what we have. Okay. On this next one here, now we're working with exponents, power exponents. So as you can see, we have 2rt to the 3rd, and everything is raised to the 2nd. So remember, when a variable does not have an exponent, it really means it's raised to the 1st. So this r here is going to be to the 1st, and s is to the 1st as well. So you need to distribute the 2 to all terms, or to all, so you need to distribute the 2 to each one. So really, you're going to have 2 to the 2nd, r to the 1st times the 2, s to the 1st times the 2, and then t to the 3rd times the 2. And then we can simplify this. 2 to the 2nd means it's 2 times 2, which is 4. a power to a power, really here you're just multiplying them. 1 times 2 is 2, so r to the second. 1 times 2 is 2, so s to the second. And then 3 times 2 is 6, so it's t to the 6th power. And this here is it. This one here, we'll do similar things. We're going to go ahead and distribute this 2 to all terms. To the a to the third, I'm going to go ahead and distribute it to this 2 and then to this b to the second. So really you're going to have a to the third times a 2 over 2 to the second, b to the second times a 2. So a to the third times 2, that's really a to the 6th. 2 squared, 2 times itself is just 4. And then b to the second times a 2 will just give you 2 times 2, which is 4. So b to the 4th power. These are different bases. I can't do anything else with it, so that concludes this problem. On this set down here for problem 7, 8, 9, we are asked to evaluate the exponential expressions, use the properties of exponents if needed. Okay, so we actually want an actual value if we can. So number 7 has 3 to the third times 3. So remember, again, 3 is really to the first power, right? So these have the same base of 3. And as you know, when you have the same base and you're multiplying them, you end up adding your exponents. So it's 3 plus the 1. Okay, so that's 3 to the 4th. 3 to the 4th does not mean it's 3 times 4. It means 3, you write that base 4 times. It's 3 times 3 times 3 times 3. Okay, so 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. Or you can simply type this to your calculator, 3 caret 4, and it will give you 81. Okay, number 8, you have a negative 5 to the second power. So this means it's negative 5 times itself. Negative 5 times another negative 5. So as you guys know, when you times a negative by a negative, you end up with a positive. So negative 5 times negative 5 is a positive 25. Okay, number 9, you have this expression here, or this exponential expression that's raised to a power. So in number 9, we are going to go ahead and distribute this 3 to this coefficient, 2 to the x and to the 4. So you have 2 to the third. X is really raised to the first power, so think of it as x to the first times a 3. And then y is raised to the 4th, but you need to times that by a 3 as well. 2 to the third means it's 2 times 2 times 2, which is 8. X to the 1 times 3 is just 3. Y to the 4 times 3 is 12. So it's 8x to the third, y to the 12th. And this here is completed. Now that we are done with this independent practice, you are going to go ahead and go to Math Excel and practice concept 1300A on there before you can move on to concept 1300B. Thank you.